Hello, today I'm going to show you the update of the GHRSST multi-product ensemble, hereafter the GMPE product. A brief introduction of GMPE. It is a system that produces a medium product using the participating L4 analyses. It also provides validation of the matchups for the GMPE medium and each of the L4 analyses against Argo observations. At the moment, GMPE uses 11 L4 products, most of which are GHRSST formats, but not all of them. Here is a list of the products if you're interested in what they are. In this presentation, I'll be focusing on the impact of potentially adding 3 new analyses in GMPE. One is the MER quarter degree, which is the smooth version of the full resolution MER that's already in GMPE. The second one is NCEI AVHRR OI. The third one is ODYSSEA, which is the replacement of Austere in Copernicus. So we have 2 pre-operational trials, including all 3 new analyses, in addition to the 11 L4 analyses in GMPE, run for 2 3-month periods, from December 2022 to February 2023, and from June to August 2023. The results will be analyzed in typical way for monitoring GMPE is to look into the anomaly to GMPE medium and the horizontal gradients, as well as Argo statistics. The Argo profiles are sourced from the Met Office EM4 analyses. The first section will look into the anomaly to GMPE medium and the horizontal gradients. The first results I'm showing here is from the winter trial, random selected date of the 7th of December 2022. From left to right, there's NCEI AVHRR OI, ODYSSEA, and the MER 0.25 degree. The pattern indicates the difference of each of the analysis to GMPE medium. So the darker blue indicates colder bias, and the warmer color indicates warmer bias. So in terms of the pattern, the AVHRR OI looks a bit more different to the other 2 by having more patchy pattern. They have patches of differences to GMPE medium, whilst the other 2 seems to be more distributed and across the globe. And the AVHRR OI has slightly warmer tone compared to the other 2, meaning they're probably slightly warmer than GMPE medium. But for all the 3 analyses, the difference to GMPE medium are within 1 and -1 degree, so it's not a huge difference. In terms of the horizontal gradients from the same dates, all 3 analyses shows very sensible gradients, with the highest SST gradients in regions where you expect for more turbulence, such as the west boundary currents, ACC region, so they all look fairly normal. Now I'd like to draw attention to the comparison between the 2 versions of MER, the full resolution and the MER 0.25 degree. So for the left 2 panels, the top one is a full resolution, the bottom one is the 0.25 degree version. You can see the smooth version appears to have more gray areas against GMPE medium than the full resolution, meaning it compares better against the GMPE medium, but it doesn't mean that the smooth version is a better analysis. In terms of the horizontal gradients, the difference probably clearer, where the full resolution appears to be more noisy than the quarter degree resolution. But again, it's hard to say which one is definitely better than the other. These following 3 slides will be exactly the same as the previous 3, but just for different time periods. And this time is for the 31st of August 2023. And again, from left to right, you have the AVHRR OI, ODYSSEA, and the MER 0.25 degree. And again, in terms of the pattern, for the anomaly to GMPE medium, AVHRR OI appears to be slightly more different to the other 2, where the difference seems to be more patchy, more bigger chunks in one region, while the other 2 are more dotted around the globe. But again, for all three analyses, the difference to GMP medium are within a relatively small threshold, so it looks all normal. The horizontal gradients, again, similar to winter results, the high gradients are exactly where we expect them to be. But for more detailed analysis, probably would like to zoom into each individual region since that is looking global. But here, just like glance at the results, it all looks very sensible. In terms of difference between the full resolution MER and the 0.25 degree, similar to winter results, it appears the smooth version have more gray areas compared to GMP medium, and the horizontal gradients also appears to be less noisy than the full resolution one. So we'll look into next to the Argo statistics as we can tell how the L4 analysis compares to Argo observations. As to most L4 analyses, the Argo observations are independent, so it could be a good way to validate how well the quality of the L4 analyses. So we'll look into time series of the mean difference and standard deviation, as well as regional and globally average statistics. The first is the global mean difference to Argo. Each line represents an analysis and it's all done by analysis minus Argo. So positive values means the analysis is warmer than Argo and negative means they're colder. So among these 15 lines, there's only one analysis appear to be warmer than Argo, which is the NCEI AVHRR OI in this light green color. All the rest are colder. And majority of the analyses distributed somewhere between minus 0.05 Kelvin to minus 0.15 Kelvin colder than Argo. Just to highlight a couple of analyses that we're interested in. So the GMP medium is a black line somewhere around minus 0.05 Kelvin here. The ODYSSEA is a dark green, which is very similar to GMP medium. The MER full resolution is this yellow line, and the quarter degree is a dark blue line, kind of going similar trend. The ODYSSEA is a darker brown, which is around 0.07 minus 0.07 Kelvin in here. So the next, we look into the standard deviation of each of the L4 analysis against Argo. And again, it's analysis minus Argo. Just to note, we consider the standard deviation against Argo a best indication of the quality of the L4 analysis. So here I'll separate them into kind of roughly two groups. So one groups of the L4 analyses having a standard deviation against Argo above 0.4 Kelvin and one group below. So amongst the above 0.4 Kelvins, the ones we kind of focus on here is the MER in the yellow and the MER 0.25 in dark blue. But just to note, for the MER analyses, because we have longer term statistics in-house, and we know this seems to be higher than where they usually are. So we think MER probably having some problems in this period, but we don't know exactly what happened there. In terms of the other analysis we're interested in, the ODYSSEA is a dark brown, which is just below 0.4, similar to the AVHRR OI. ODYSSEA is dark green, which is around 0.35, similar to the GMP medium. But they all are of reasonable kind of standard deviation, so they're all of reasonable quality. Similar results to before, but for summer periods. And this time there's only one analysis warmer than Argo, which is MGD-SST. The next following Argo, following the trend is the MER 0.25 in dark blue. And then the next one is the NCEI AVHRR OI. So they are seems to appear compared very well against Argo in terms of the mean difference. The majority of other analyses can again distribute somewhere between minus 0.05 and to minus 0.15, so it's colder than Argo. In terms of standard deviation, and this time again separating them into two halves, one half where the analysis having a standard deviation above 0.45 Kelvin and the rest below 0.45 Kelvin. So for all the analyses that we're kind of focusing on in this study, they're all below 0.45 roughly. The ODYSSEA seems to kind of go slightly above, but it's very close to that line, so it's also a very reasonable result. The NCEI AVHRR OI is about 0.42 maybe. The two MER analyses this time go below 0.45, so it's the normal level where they should be. GMPE median has the smallest standard deviation, which is above 0.35. The austere is about 0.38. So they're all good quality. And look into the averaged statistics. So I chose the global statistics. The North Pacific is mainly because we had some discussion about AVHRR OI being different to other L4 analyses around that region, as well as South Atlantic, just another region in the South Hemisphere, but it's not in Pacific, so giving you a kind of different flavor, a different region. And the bold number indicates the best results in each of the category, each of the region. So the top three lines are the mean difference, and that shows the GMPE median austere, the three new analyses, as well as the full resolution MER. So you can see for winter time, the AVHRR OI appears to compare really well against Argo in the mean difference. And in terms of the standard deviation, austere appears to be really well compared to GMPE median and smaller than all the other four analyses. In the winter time, it has slightly more complicated picture where the MER 0.25 appears to be compared against Argo really well in the global ocean and North Pacific, have the best statistics. And the NCEI AVHRR OI compares best against Argo in the South Atlantic, where austere appears to be struggling a bit. In terms of standard deviation, though, the GMPE median has really good standard deviation against Argo as well as austere. And again, these two columns show smaller numbers than the rest of the L4 analyses. And just have a special note on the use of Argo observations in the L4 analyses. As I mentioned earlier, so majority of the L4 use Argo as completely independent observations for validation reasons, but the AVHRR OI and the tumor do assimilate Argo during their production process, which means Argo are not completely independent for them. So in the Argo statistic here, we see the AVHRR OI and the MER compare pretty well against Argo, especially when the analysis being normal, not considering MER in wintertime. But the standard deviation doesn't seem to be significantly better than the other analyses. So it's hard for me to just assess if that's because the assimilating more Argo, or is that because some other processing chain when they produce the products. So a better comparison would be to have a one L4 analysis and comparing with Argo and without Argo. That would be a clean comparison of the impact purely from Argo, because if I run GMPE including L4 assimilating Argo versus not, then it's hard for me to tell if the impact are from excluding a couple of analyses or excluding the impact from Argo. In terms of our plan, we're going to include AVHRR OI and ODYSSEA in our next two system upgrades. And in terms of MER, we decide to contain the full resolution version because it has a better user community already, and it might contain some information which has been smoothed out by other L4 analyses. And also because the quarter degree MER was produced as part of the coverage project, the coverage has since completed, so we don't know if it's going to be produced in the longer term. And here's everything from me. So if you have more questions of the GMPE products, and if you'd like to have more information, please do not hesitate to contact me. Thank you.